So we are going to start 12.1, which is a vectors chapter, and the first section is on page 337. And the first thing that they want you to learn is how to find the distance of a 3D coordinate from its origin. So the distance from the origin to the point x, y, z in this order is basically is just Pythagoras, but for 3D coordinates. Okay, so essentially you're actually doing Pythagoras twice. Once x squared plus y squared square root, and the other one on the answer and between this coordinate. So you can just do that in one go, and you've learned this at GCSE. So the example one is find the distance from the origin to the point P, and that point is 4 minus 7 minus 1. And if I wanted to find that distance, that would be OP, and I would simply just do this, and okay, so that's just the first example. Then the next example says you can also use Pythagoras' theorem to find the distance between 2 points in exactly the same way as you've learned how to find the distance between two coordinates, and you've learned this in book 1 actually. But you can do exactly, you can use the same principle for two 3D coordinates. So if I've got x1, y1 and z1 as one coordinate, and x2, y2 and z2 as my second coordinate, then the distance between these points, let's call them A, B, would be the difference between the x coordinates plus the difference between the y coordinate squared. And if you choose to do x2 minus x1, you've got to do the same for all the other coordinates. z2 minus z1 squared, square root. Okay, and that will give you that distance between the 2 points. So example 2, 2 points, A, 1, 3, 4, and then it gives you B, 8, 6, minus 5. And it says give your answer to one decimal place. So AB equals 8 take away 1, 7 squared, plus 6 take away 3 squared, plus minus 5 minus 4 minus 9 squared. And if I do this, I will then get root 139, which is 11.8 to 1 decimal place. Okay? Example 3 says that I've got two coordinates. A is 5, 0 and 3, and B is 4, 2 and K. And it says given that the distance between A and B is 3 units, find possible values of K. So given AB is equal to 3, find possible values of K. So 5 minus 4, 1 squared, plus 0 minus 2 squared, plus 3 minus K. 3 minus K squared, square root equals 3, which means 1 plus 4 plus 3 minus K squared equals 9. 3 minus K squared plus 5 minus 9 equals 0. So I've got, if I expand out this bracket, I'm going to get 9 minus 6k plus k squared minus 4 equals 0. I am going to form a quadratic. K squared minus 6k plus 5 equals 0. And that's going to give me k minus 5, k minus 1 equals 0. And that gives me either k could be 5 or k could be 1. Okay?